I want to say something about reaction types. And as I mention these classifications of reactions, what we'll see is that many reactions can belong to, can be more than one type. So a reaction could be, for example, a combustion reaction. That's one classification. It could also be a combination reaction. But at any rate, so the first thing we'll introduce is a so-called combination reaction. A combination reaction, right there, is when more than one substance combines to form only one compound. There are some examples. Notice here we have NH3 gas, HCl gas, two reactants, one product, a combination reaction. Hydrogen gas, oxygen gas, one product, H2O, so it's a combination. Ammonia and hydrogen gas makes, nitrogen and hydrogen gas makes ammonia. Again, one product, that makes it a combination reaction. A decomposition reaction is simply the opposite of a combination reaction. For these, notice that we have, in a decomposition reaction, instead of one product, we have one reactant. One reactant decomposes, we say, into more than one product. So calcium carbonate makes calcium oxide and carbon dioxide. Combustion reaction is another classification, and combustion is generally, most generally, a reaction of something with oxygen gas. In these two examples, the reaction we can see is also a simple combination. So magnesium reacts with oxygen to make magnesium oxide. So magnesium burns in the presence of oxygen, produces one product. That makes it a combination reaction, but it's also a combustion reaction because it's a combination with O2. Hydrogen gas burns, and again, that is a combustion reaction as well as a combination. Also, another example of a very important class of combustion reactions are those that involve organic molecules, particularly those like things like hydrocarbons. And when we carry out a combustion reaction, if it's a complete combustion, we produce carbon dioxide and water. So make these two products from all the carbon and the hydrogen in the compound. And so here is a couple of examples of balanced combustion reactions. A very important one, methane, that's natural gas. This one burns in oxygen to produce CO2 and water. And again, you should confirm for yourself that this equation is balanced. The other one here is the one I did earlier. That's the combustion of acetylene. And we demonstrated balancing that one earlier. Here's a couple of examples of balancing combustion reactions in particular. And this one would be the combustion of propane. And so we will do, these are things that I might give you on exams, where I just simply ask you to write a balanced equation for the combustion of propane. Of course, that's going to require that you know what propane is. C3H8, and that's going to, and a complete combustion reaction is going to be a reaction with oxygen to produce CO2 and water. Okay, and I proceed as I did before. First, balancing the carbons. I see I need a 3 here to balance the carbons. Now I look at the then I look at the hydrogens. I see I have 8 hydrogens on the left, and so I'm going to need 4 water molecules. And then finally, the oxygen atoms. I see I have 4 plus 6 makes 8, makes 10. So I need 5 oxygen molecules on that side. And that equation should be balanced. Here's another example, the combustion of ethanol. And again, I have to know what ethanol is. C2H6O plus this. I can't forget that that my starting material also has oxygen in it. Plus O2. Goes to CO2 plus water. Now I proceed as before. Balance the carbons first. Put a 2 here. Balance the oxygens. Balance the hydrogens. I need a 3 here. And now, 2 there, 3 there. And now I look at the oxygens. I see I have a total of 4 plus 3 equals 7 on this side. I already have 1 in my ethanol molecule, so I